Bismillahirrahmanirrahim. Good evening, everyone. Today we will try to solve two examples about the independent voltage source. We will analyze the circuit by use the Kirchhoff voltage law and Kirchhoff current law. Let's start to solve this circuit. We have two independent voltage source. We can see VS1, VS2, or VSVG, and two different amounts of resistance. 100 ohm to 100 ohm. We have two nodes, or we can say junctions, D1, D, and J. And here, like we see, the current number 1 going directly to node D. Here, I2, I3, resistant 1, 2. We can say this loop 1, or we can say C1 here, loop 2, or we can say C2 with clockwise, C1 and C2 with clockwise. Now, determine the current through the voltage across and the power dissipated by the two resistors. At first, we will try to calculate some equations related with the current. After that, determine I1, I2, I3 results. And after that, by using Ohm law, we will know by using the voltage, Kirchhoff voltage law, we will calculate the voltage at R1 result and the result of V at R2. Let's keep going to solve this question. At first, I1 equal, like the pipe of water, I1 equal I2 and I3. I write it here. I3 through from the resistance here. That's mean here we will see a drop voltage because the current through from the resistance. That means here we note drop voltage. But at first here equation by using Kirchhoff law, Kirchhoff current law, we can say I1 equal I1 minus I2 minus I3 equals 0, because the last amount of the current and the voltage at the Kirchhoff current law voltage law must equal 0. Here, that means we have a voltage drop, like I said before, from Kirchhoff current law, I1 minus I2 minus I3 equals 0. Now let's work at loop 1. From Ohm's law, V equal IR, V1 at resistance 1. What that means from Ohm law equal I3 dot R1. But here voltage at R1 will equal minus, because like I said before, we have drop voltage. I3 R1 after the resistance, that means we have a voltage drop, the same meaning, the same situation with the voltage at resistance 2. Here, that's mean V1 equal minus I3 dot R1. Like I said before, that's mean we have voltage drop. Now, let's write the V total equation equal V drop at R1. Let me use this image. V total at loop 1 equal minus V at R1 plus the voltage source, because here from the minus to positive, we must put positive between these two amounts. Like I said before, minus I3 dot R1 plus VS equals 0. Now let's work on the loop 2. And we can say I3 minus I3 dot 100 ohm, like we know here, 100 ohm plus 1.5 voltage equals 0. Let's say this equation number 2. Now at C2, at loop 2 here, we have two amounts of resistance, 100 ohm and 200 ohm. Let's start from D node. The current I2 go directly to VG here from positive to negative terminal. That's mean here we will put a minus, and after that the voltage drop at R2 will equal minus, because through from resistance number 2, 200 ohm equal, yes, the V total at loop 2 equal minus VG minus the voltage at R2 plus the voltage at R1. Let's discuss why here the drop at resistance 1 equal positive, because here I2 coming from here and go directly to node D from node G, reverse with I3 here, because this two reverse currents, we will write plus instead of minus behind the voltage at resistance 1. Let's keep going. That means minus VG minus voltage drop at R2 plus the voltage at resistance 1 equals 0. Let's put all of these results here at this equation. Minus 9 voltage equal, like I write it here. Now, let's, from Ohm law, voltage at R2 equal I1 dot resistance 2, I1 dot 200 ohm plus voltage at R1 was current 2 dot 100 ohm equals 0. Now, like we know, we have three kinds of currents, unknown three elements. We have I1, I2, and I3. Let's start to calculate I3 from equation from Kirchhoff voltage law, equation number 2. Let's keep going here. I3 equal 1.5 divided on 100 equal 15 milliampere. Now let's try to calculate R3 from equation 3 at the Kirchhoff voltage law. Here I2 equal minus 0.0375 ampere. What that's mean here? The minus here, that's mean the current going to the reverse direction. Now let's calculate I1 from equation number 1. Like I said at the first lecture, I1 equal I2 plus I3, I1 equal minus 22.5 milliampere. And if we say, like equation number 2, I1, like I remember, I1 minus I2 minus I3 must equal 0. That means we calculated it by using right way. Here minus I1 is, that's mean the current direction is incorrect direction, it's reverse direction in the circuit of the positive charge flow. Now we can determine the voltage drops across the resistance. We have two resistance of voltage drop at resistance 1 and 2. By using Ohm's law, that will be easy, because voltage at resistance 1 equal I3 dot R1, that's mean 1.5 voltage, and drop voltage at resistance 2 equal I2 dot resistance 2 was 200 ohm equal minus 7.5 voltage. Now, to can calculate the power, like we know the power law equal current dot voltage. Now we have the both of them, we can calculate the power at resistance 1 equal I3 dot the voltage at R1, and the result equal dot 225 watt. And the power at resistance 2 equal the current number 2 dot the voltage at R2 equal 281 milliwatt. Now let's go to solve the second question. Let me see. Oh my gosh. Let me just do a new share. Yes, this is the second question. We will try to solve it. Here we have three kinds of resistance, but actually the author selected same amounts to us to make our process be easier. Now we have two circuit loop or two loop directions. We can say C1, C2, like the last exam question, sorry. And we have two different independent voltage source. Number one, VS 12 voltage. The VG, the second independent voltage source, equal 15 voltage. And here the current IS, we can say I1, or the current source equal I1. The same thing equal I2 plus I3, and after that, like the Kirchhoff law, current law, we can say I1 minus I2 minus I3 equals 0, because the last amount of current equation must be equal 0. And let's work on this. I selected this node N to be the reference point. Honestly, I take all these two questions from internet, but I solved it by using more details to make these two questions be clear to us. Now let's work at node A. Or let's work on loop C1. Here we have now let's start to write the equations about the Kirchhoff voltage law. We will work at first on the loop C1, start from VS, going to the voltage drop on R2. After that, going to the voltage drop at R1, and all these three different amounts, when we calculate them together, will equal 0. And the same idea, we will use it with C2, and we can say we have loop 3, it's equal both of them, C1 and C2. Let's go directly to details to cancel this question. Now I write the Kirchhoff law, Kirchhoff current law here, and after that going directly to voltage, Kirchhoff voltage law. Here at C1 loop, Vs plus V drop at R2, that's mean minus, plus V drop at R3, that's mean minus, equals 0. From Ohm law, V drop at R2, because of drop, that's mean minus, I3 dot R2 V drop at R1 equal minus R1 I1 R1. Now let's put all of them here at the general equation at C1 loop. That's mean 12 volt minus I3 R2 minus I1 R1 equals 0. Let's say this, let's name this equation number 3. At C2 here, or let's image the image, the main picture. Here, we will start from A node going to the VG, and after that, VG will be from plus, the current direction will be from a plus to minus, and after that, going directly to R2 and to, to R3 and come back to R2 to be at the same node from the start point. We will start from point and we will finish this direction at the same point, because that all equations at the current at Kirchhoff current or voltage law will equal 0. Here we had VG and V drop at R3 and R2. I will start from node A, from B node, to A node. That's mean I will start from here and finished at A. We can say the direction will be like that. But I will start from B to A. That's mean here the drop voltage R2 will be plus, not minus, positively, not negatively. Let's go to the details. V increase at R2 will equal I3 R2. The main equation here will be I3 R2 minus 15 volts VG. Here the VG will decrease from positively to negatively terminal, because that I write it minus VG minus the drop at resistance 3 equals 0. Now at loop C3 we will start from VS going to the, we will see drop here because from plus to minus terminal, going to drop at resistance 3, going to drop at resistance 1, and come back to VS. Let's see what will happen. At loop 3, VS minus VG minus V drop at R3 minus drop at R1 equals 0. That's mean, like we're seeing here, if we be sure from our solution, we can calculate the loop at C1 plus loop at C2. We will see equal loop at C3, like I write it here. Now let's go to try to calculate the currents from voltage equations. Like I said before, we have 3 unknown amounts of current, I1, I2, and R3. Now from equation the voltage at loop C1, we can calculate I1, what it's equal, like we're seeing here. The author gives us the same amount of resistance. All of them were 22 ohm, like I remember. I1 equal 12 volt minus R3, R2 divided on R1 from voltage at loop C2. Let's start to calculate I2 equal I3 R2 minus, that's mean the drop at resistance 2 minus 15 volt divided on R3. Now we know R1 equal from equation number 1 equal I2 plus I3. That's mean here I3 equal 9 volt divided on 22 ohm. We can say equal 409 milliampere. Now, after that, let's come back to calculate IC2. And after that, by using equation number 1, we can calculate current result number 1. Current number 1, yes, that's right. Now to calculate I1 from loop C1, 12 volt minus I3 R2, the drop at the resistance 2 minus I1 R1 equals 0, we can put the result of R3 409 milliampere here in this equation to calculate the result of IC1, or we can work directly to IC2, and after that, if that's available, if we have the result of R2 at the second equation of voltage, Kirchhoff law, we can do that. But here I started to calculate, I started to calculate I1, and after that calculated I2. Here I1 equal 137 milliampere. Now just we have I2, and we will calculate all of these currents. Here I2 from equation number 4 from Kirchhoff voltage law, I2 will equal minus 272 milliampere. Why minus? Because here the current flowing to the reverse direction. Now let's calculate from Ohm's law the voltage drop at R1 and R2. From Ohm law equal, we can say 3 volt, and at R2 equal minus 5.98 volts. And the last resistance was equal minus 5.98 volts. That's it. Our lecture today is done. The next lecture, I will try to explain the relation between the resistivity and the conductivity, and we will use some examples to solve it together. Thank you so much for your patience and your time. Have a good day.